Evaluate each expression. This is 1.5 times 1.5, which is 2.25. All you need to do is evaluate the remaining 4 problems. Compare the following tables of values. Record your observation in the space provided. In this first table, I see that the x values are increasing by half each time. And I see the y values are also increasing. In this table, I see that the x values repeated. And some y values also repeated. So this one wasn't always increasing. At the beginning, it didn't increase. But then this one has the 0.14 and the 0.136. Is it possible to be 4 feet of distance at 1 second, but also be 36 feet at that same time? Table B is not a function. It does not define a function because it's impossible for an object to be in 2 different places at the same time. However, it is okay that it doesn't move. So for example, in half a second, it went 4 feet. And then if it stayed in the same location, at 1 second, it would still be at 4 feet. Table A is describing the dropping fish function from the previous lesson. And so it shows over time that the fish's distance from the bird is increasing as it drops farther and farther to the water. A fish is released from a height of 256 feet. Complete each statement by using the rule for the function that relates the distance traveled in feet to the time in seconds. So it says the function assigns 4 to 0.5. If we go back, it assigns the value 4 to the input 0.5. Here it says it assigns something to 1. Well, at 1 second, it was assigned the value 16. So we'll fill in 16 in that blank. The function assigns blank to 1.5. So looking at the value 1.5, it's assigned 36. Now it's backwards. It's going to give us 64, and we have to decide what time interval that was. So 64 was 2 seconds. 100 was 2.5 seconds. For 3 seconds, we used 144 feet. For 196 feet, it took 3.5 seconds. And in 4 seconds, it drops 256 feet. So you can think of these as your x values and these as your y values. A function is a relationship or a correspondence between a set of inputs and a set of outputs. Typically, we describe these inputs as x and outputs as y, so that each input corresponds to one and only one output, meaning You can't be in two places at once. You can only be in one spot. Each input, each x value has its own y value. You can't have 1, 4, and 1, 16, because 1 has to only have one output that matches. On page 27 in your workbook, you have a graphic organizer. In the box labeled description, I would like you to write the definition. We're going to return to this page 27 in future lessons to add more detail to that graphic organizer. Let y equal 16x squared, where y represents the distance traveled in feet after x seconds. Use the equation to complete the table of values. So we're going to plug in 0.5. 0.5 squared is 0.25, and 16 times 0.25 is 4. 16 times 1 squared, well, 1 squared is 1, and 1 times 1 is 16. $1.5 squared is 2.25, and 2.25 times 16 is 36. 2 squared is 4. 4 times 16 is 64. 2.5 squared is 6.25. Then multiply that by 16 and you get 100. Continue plugging in the values of x into the equation to determine the output. Then it says in part B, do the distances you calculated in part A match the values from table A in problem 1? So if we go back and look at table A, do our values match table A? Yes. Does the equation y equals 16x squared accurately represent the function? In other words, does the equation assign the correct distance to each time? Explain. Yes, the equation accurately represents the function. Each calculation using the equation gave us the correct output. For each time that we input. Identify what other input values make sense in this context. So any value from 0 to 4 seconds would make sense in this because the fish was released at 0 seconds and it hit the ground or the water at 4 seconds. Use the equation to find the distance that a fish has traveled after x seconds for a value of x not shown in the table. So we're going to pick a value that wasn't represented in the table, such as 2.25 seconds. And we're going to replace the x value with 2.25 and solve it for y. So we have 2.25 squared, and then we're going to multiply that value by 16, which gave us 81 feet as our output. So in 2.25 seconds, the fish has fallen 81 feet. Consider the following table. Does the table of values represent a function? Explain how you know. Each input has its own output. It's okay for it to be in the same location at different times, but it is not okay for it to be in two places at once. Describe what you think the rule is that assigns inputs to outputs. If I look at this 2, 2, 56, 5, well, that starts with a 5. 123 starts with a 1. 3046 starts with a 3. 3861 starts with a 3. So I believe the rule is that it assigns each number the first digit of the number. C. Identify what other input values make sense in this context. Any number could make sense. Identify whether you can write an equation to represent this relationship. Then write it if you can. Well, this isn't a straight line. And it's not a function that we're familiar with. Even though we know the pattern, we don't have a formula or a template to write an equation. The table included the input 300,411. What output would you expect the rule to assign to it? Well, since 300,411 starts with a 3, we would expect that the output would also be 3. For problems 5 through 8, identify whether the table represents values of a function and explain your reasoning. Here I see that 5 shows up twice, but it has two different outputs. Remember, the definition says that it can have only one output for each input. So no, this is not a function. Because two different outputs were assigned to the input 5. This one, I don't have any repeating inputs, so yes, this one is a function. Seven, each of the inputs all have their own outputs. Again, it's okay for 10 to go to 32 and for 20 to go to 32, as long as 10 doesn't go to two different spots, or 20 two different spots. So 7 is also a function. Number 8, 7 shows up twice in the table, but the output that it assigns to it is the same. So yes, this is a function because 7 still only had one output. Even though it showed up twice in the table, it went to the same location both times. So it is a function. This idea of a function is kind of difficult to grasp in the very beginning. I would recommend watching some additional YouTube videos, and I can link some in the description so that you have more of an idea of what a function is and how to know whether it is a function or is not a function.